Hi, my name is Eden Kim and welcome to the virtual SDC 2020. Today we're going to talk about real-world edge workloads and application and storage optimization. In today's example of the real-world edge workload, we're going to be looking at a GPS navigation edge workload and using it to optimize artificial intelligence, machine learning, LSTM RNNs. LSTM stands for long short-term memory. RNN stands for recurrent neural networks. So in this case, we're going to look at a GPS nav workload that's being used to be optimized by LSTM RNNs. However, we will be looking at LSTM RNNs as a black box. We'll be looking at only the input levels and the output levels. The rest of it will be a black box. So what's the difference between a synthetic and real-world workload? A synthetic workload tends to be a corner case stress workload that stresses storage outside the range of normal usage. Real-world workloads are comprised of constantly changing combinations of different I/O streams. Corner case workloads are comprised of a single or very few I/O streams applied over a defined period of time. On the other hand, real-world edge workloads have many I/O streams, hundreds to thousands, that change over the course of a workload. Corner case workloads have traditional transfer sizes, half K, 4K, 8K, so on and so forth to 1 megabyte, whereas real-world edge workloads have non-traditional transfer sizes from byte size, such as 10 byte, 28 byte, 60 byte, 128 byte, to small block, 1K, half K, 1.5K, and so on. Finally, corner case workloads have a fixed demand intensity or queue depth. Real-world edge workloads have a constantly changing demand intensity. So what are some examples of real-world edge workloads? Well, you have artificial intelligence, you have genetics and genomics, 3D animations, cloud storage, big data, web portals, machine learning, and 5G edge servers. Today we're going to look at a blend between artificial intelligence and machine learning, cloud storage, web portals, and edge servers. So let's take a closer look at a real-world GPS nav edge portal workload. Here you can see an I/O stream map of a 24-hour GPS edge portal workload. In this case, on the bottom, you have time, which is in minutes, 1,440 minutes, which equals 24 hours. On the x-axis, you have I/Os and I/O streams. You'll note that the orange line for queue depth shows a changing queue depth from the beginning to the end of the workload, varying from 6 to 368. The tall colored bars are individual I/O streams. In this case, we're looking at the top 9 I/O streams that occur over the 24 hours, covering a variety of different events, such as early morning boot storm, 2 a.m. backup, opening hours, or in this case, for the GPS nav, you're seeing constant I/O demand to the GPS nav portal with 4 distinct I/O spikes of half K writes. Looking at the top 9 I/O streams, we can notice that they are mostly a write workload, and there are actually 1,033 streams over the 24 hours. However, we are capturing the top 9, which are sequential 4K write, random 16K write, and so forth, all the way down to sequential 1.5K write. If we look at the process IDs, or the applications that are assigned to each I/O by the kernel, we can see that it's dominated by MySQL and also SQL Server exec. Where we capture the workload is very important. This is because I/O streams change as they traverse the software stack. In the first case, we're looking at using IO capture tools from testmyworkload.com, which give you a free tool that you can capture the file system or block level IO streams from your target server. In the simplest case, we look at enterprise storage, and we can put the IO profiler on the file system and capture IOs that go to storage, whether it be NAS, SAN, persistent memory, direct attached storage, computational, object, or other. In addition, we can put the IO profiler at the block IO level and capture IOs directly to storage. In the Fabric case, we put the IO capture tool on the host server and capture the IOs that are sent across the wire to the target server. You can also put the IO capture tool on the target server and again capture any IO traffic to the recognized logical storage. In the virtual machine case, we can put the IO capture tool on the virtual machine and then go across the Fabric to the enterprise storage. In any case, we can use this IO profiler capture tool to capture any direct, remote, or Fabric storage IOs. When we look at artificial intelligence workload capture, we're looking at the capture, curation, and optimization using the IO profiler metrics. In the first case, when we look at the IO profiler, we can see that we are not capturing any personal data, that actually we capture the IO statistics in a series of steps with a granularity from a microsecond to minutes to hours. All of the IO streams over an individual step are averaged and presented on the IO stream map. This allows you to capture very long workloads without the attendant huge amount of data. The IO capture tool also allows you to capture edge transmission. You can easily transmit IO packets from the edge. You can use real-time streaming steps, as well as use phone home telemetry to give you alerts to what's going on with the edge workloads. This continuous monitoring allows you to view the continuous IOs that go into your database. You can then replay the workloads to see a real-time or historic workload, as well as monitor multiple nodes, servers, and drives. When we monitor the workloads, we look at key performance indicators, such as block size, read-write mix, reads or writes, IO bursts, trims, queue depths, and etc. When we look at these and rebuild the workloads, we can then curate the workload and filter out or parse the workload to see those application IOs of interest. You can look at time ranges, you can look at storage LUNs, LBA ranges, as well as structured data and applications. Once we have a curated workload, we can create a replay test. This replay test replays the sequence and combination of IO streams, queue depths, and metrics to targeted storage and allows you to optimize storage or otherwise use it for training with artificial intelligence. Finally, these replay workloads can be used to qualify, validate, and evaluate storage at the data center level or at the individual direct attached storage level. Looking at artificial intelligence in the IO profiler, there are three basic steps. There is gather, which is the workload capture step where you capture, curate, and script your workload. The second step is training, where you look at the replay test. You can queue up many tests in a loop and replay them. And then finally is the inference step, where you can optimize your storage, validate, simulate, and apply your workload. Looking closer at the gather step, we can see that the LSTM RNN workload IO capture tool allows you to capture the IO workload at the input layer or the output layer. The LSTM RNN area is a hidden layer. So what we see is we see the real-world storage workload going to the input layer and then emerging through the output layer to the nodes. So we can capture the workload at either the input or output layer for analysis or for training. So again, at the gather stage, we're looking at capturing edge data, I/O input and output layers. We're looking at curating the script by selecting key performance indicators, and we're scripting the curated workload to create a replay script. In the second step of training, we have the replay test. Here we're looking at an AI ML workload training replay test and loop. On the left-hand side, you can see a repeat of a variety of tests going to our storage. We can monitor the key performance indicators for each of these tests as they loop, and then the data scientists can apply the key performance indicators to optimize the test within the context of the LSTM RNN. So for training, you are replaying the test, you are queuing up multiple tests in a list, and then you are looping these tests so that you can further optimize via the LSTM RNN algorithms. In the final step, you're looking at inference or optimization. In this step, we're looking at optimizing the LSTM to improve the performance of the storage. So we are looking at the key performance indicators over time, and then with each iterative run, you can see that you can improve your key performance indicators, in this case, IOPS and response times, by applying the key performance indicators to your optimization algorithms. So in the third step of inference, we apply or we run the LSTM RNN AI algorithms. We simulate by optimizing performance gains, and we validate by utilizing edge transmission, continuous delivery integration to monitor with real-time telemetry. So what do we mean by monitoring with real-time telemetry? We can use the I/O capture tool to look at our workloads on the edge and transmit these workloads to our database and monitor the key performance indicators. So in this case, you are validating your AI algorithms by ensuring that the edge workloads continue to behave and continue to present the same type of workloads as those workloads you use to optimize your LSTM. Secondly, you can phone home key performance indicator alerts, such that if you see a key performance indicator outside the range or expected range, you can get alert and then capture that point in time or otherwise examine your underlying algorithms and workloads. So this is just a brief look at how you can use an I/O capture tool from testmyworkload.com to check the input and output layers of your real-world edge GPS nav workloads. So in summary, you can use application storage performance and look at it in terms of the workload. We notice that the workload changes as they traverse the I/O and software stack. Real-world workloads are very different than the synthetic workload counterparts. You can capture your real-world workload with free I/O capture tools at testmyworkload.com. And you can curate and train AI workloads using the I/O Profiler toolset. So there's no reason you can't optimize your application and storage by monitoring and curating your key performance indicators. Thank you very much. If you have any questions, you can send them to info@calypsotesters.com. Please take a moment to rate this session. Your feedback matters to us. I hope you have a great day, and thank you for tuning in.